All right, gents, how you doing this evening? Hope your life is as dull as mine is, but yeah. So I figured I would make a video and show you some tips on how to quickly get your head around a board like this. A little method that I discovered, and it really speeds up the process of figuring out how this thing works very quickly. So, yeah, you hear those little footsteps upstairs. My daughter's not quite in bed yet, so hold on a minute. I'm gonna go make sure the little thing is in bed here. About that, I had to say goodnight to my sweet little 4-year-old here. And yeah, so this method doesn't quite work perfectly for every type of board, but it actually is pretty good for this style of through hole board. Um, and yeah, it makes it really easy to understand what's going on. So let's get started with it. So I'm going to go to my computer now and make the rest of this video. Ow. All right, so this is an image editing software called Inkscape, and it is completely free. At least the version that I'm using here is completely free. It's actually a really powerful thing. It's really useful for so many different things. If you know how to use it right and you get some practice with it, the sky's the limit, really. I'm still kind of getting my head around all of the all of the finer nuances of it, but so you can see right here, I've uploaded these two photos from my phone, and the way I did that is just go to File. You can't see it here, but there's actually a drop-down box, and there's an option for Import, and you click that, and it takes you to the File Explorer where you can go into your phone and upload the images here. So I took one of the top and the bottom here, and quick rundown of what this board is. It came out of a Ream air handling unit. It's a really simple board. I will say this, this doesn't work the best with every single type of board. Surface mount stuff, you can have traces that are hidden underneath components. This is the ideal scenario for this method. Your typical through hole board only that's single sided. That is definitely where this shines the most. But yeah, it's still useful for getting your head around way a board's designed and what the engineers were thinking and stuff. So yeah, I've got my two boards here. You notice that the way this board works, a quick rundown of it is you've got your incoming power. This is where your 24-volt power comes in. You've got some high voltage protection here with this MOV and this capacitor, and you've got your full bridge rectifier right here, filter after that. Pretty sure this is a Zener diode as a shunt regulator, and they actually used a PIC microcontroller on this board for some reason. I'm not sure why it's such a simple board. I'm not sure why they needed to do this, but oh well, it's here. Um, Pretty sure these are the inputs from the thermostat wiring. So that would be red, common, fan signal, W1 and W2 for the electric heat, and Y1 for the outdoor unit. And I'm pretty sure these are the outputs that go to the relays that actually bring on the electric heat elements in the electric furnace of the air handler. And then this particular model of air handler has a variable speed ECM motor and X13 motor, and you've got multiple speed taps on that. G would be normal. I believe it would be coming off the normally closed of this relay, and the other tap would be the high speed tap that would be energized if the electric heaters were on. So I believe this would be coming off the normally closed, and this would be coming off the normally open. You could actually scrape this off and look up a data sheet for the relay to verify all that later on if you wanted to. So you notice we've got this pin header right here. It's got 6 pins, and notice it's over here. So what we need to do quickly is flip this image around and mirror image it horizontally by hitting this button. When you hit this button, it's going to flip it that way. And then let's grab this and we'll go to this menu right here, which is fill and stroke. Oh yeah, that's kind of funny, isn't it? Fill and stroke. You turn the opacity down and you can make this semi-transparent, and then you can move it over the top of this other board so you can see the top and the bottom simultaneously. Let's go ahead and zoom in a little bit so we can line up everything properly. And you can do your best to line the holes up. And the bigger your board is, the more you're going to tend to have distortions across the entire board. You might have this side line up, but this side wouldn't. But on a small board like this, it's not very difficult at all to get them to line up, and that's probably good enough for our purposes. And then once you do that, there's a locking symbol. It's kind of out of screen here, but you can lock these to where you can't move them anymore and they stay stationary. And then if you only wanted to see the top, you could block that one out. And if you only wanted to see the bottom, you could block this one out. And I've taken the time to go ahead and do some diodes here. So now you have the freedom to draw text or anything really over the top of this board so you can label the diodes with their bias markers. So now you can look at the bottom only and get an idea of what pads go to these diodes and how they're biased without having to flip it over. And even you could go a step farther and even fill in all of these traces with, say, a black color for ground or a red color for DC positive. Might have a separate AC ground and a separate DC ground. You could isolate those and write them out. And even with this PIC microcontroller, I've looked up a data sheet right here that has all of the pin designations for it. And so you could write those in tiny print on each of the pins, so this is a really good method for doing this. And even there's a transistor right here, and you could label base collector emitter, and you could very quickly get an idea of what the engineers were thinking when they designed this board and how it works. And this may aid you in troubleshooting. But yeah, this is a method that I like to use. It's a lot cleaner and faster and more organized than flipping the board over and over a million times. And you can keep this as a file for a reference later on. And you can even upload data sheets for all of the components in here and have them in the same in one area, so you're not having to bounce back and forth and look up data sheets so much. It really, if you have a board that you're working on a lot, this might really speed it up for you. So yeah, hopefully this is a new idea for you and you get some use out of it. But it's a very good method, I think, for especially in this case with this type of board. But yeah, you guys have a wonderful evening. Take care. Thank you for watching. Like, share, subscribe. Thank you for the people that have been commenting. My channel's been growing some, and I really appreciate that from the bottom of my heart. Thank you guys, and take care.